Okay, here are the examples so that you can do the work. You'll have time in class to do it the whole class period. Right here, it's asking you to analyze the particle's motion. So if you look at the velocity of the particle given the position here, okay, you would determine where there's negative velocity, it's moving to the left. Where the velocity is positive, it's moving to the right. Once you find out the velocity, you take the derivative of that. That gives you the acceleration. Okay, and that tells you whether or not it's speeding up or slowing down. Okay, so first we have to take the derivative of speed. Okay, now remember, S prime of t, that's horrible, sorry, equals vt. So to find vt, just take the derivative of the position. And you guys know that the derivative of the position here is 2t minus 6, right? Now how are we going to determine whether or not these points are positive or negative? Find out where the derivative equals 0. Okay? Where the derivative equals 0, to the left of that, we have to determine whether or not it's positive or negative, and to the right of that as well. But first, make the velocity itself equal to 0. This is what I mean. Vt equals 0. Okay? Make Vt equal 0. Vt equals 2t minus 6. Okay? And just isolate t. We're going to add 6 to one side. Okay? And divide by 2. So Vt equals 0 at 3. And that's what goes here. Where is Vt equals 0? Okay, give it up. After doing that, step 2, write out the number line, and there's the number line. Okay, right to the right is the number line. And we have 0, just mark where 3 is, and what's happening to the right and to the left of 3. And just by looking at the velocity, the equation itself, okay, if you notice 3 is where it equals 0. Anything to the right, if you put any numbers bigger than 3, then you're going to get positive results to the right of 3. You plug in numbers smaller than 3 over here, okay, you'll get negative results. Next, take the derivative. Okay, take the derivative of velocity, and again, when we have vt, the derivative of vt equals the acceleration with respect to time. So when you take the derivative of 2t, it's just simply 2. And so where does at equal 0? It doesn't. It's a constant. Okay, at will not equal 0. And because at is positive, then the acceleration is going to be positive everywhere. Because the acceleration is 2 everywhere. And take note, when you're doing these number lines, make sure they line up. Okay? Make sure they line up. Use the same scale. Okay, now step 5. We're going to describe the motion, whether or not it's speeding up or slowing down. Okay, if we have a negative direction like we do right here, okay, we have a negative direction, but we have a positive velocity, positive acceleration, this is where it's slowing down, right here, slowing down. Slowing. Okay, and because we have a positive direction right here and a positive acceleration, the object is speeding up. Okay, finally on step 6, making the position graph, you always want to start at t equals 0. And in order to analyze the position at t equals 0, let's find out what the position is at t equals 0. And if you plug in a 0 here and a 0 here, the position equals 5. So let's go to the right side of this line, and that's when position is 5. Now the other critical point is at t equals 3. We have 9 minus 18 plus 5, and this gives us negative 4. And so position negative 4, let's just put it somewhere on the left-hand side. Okay. So starting from t equals 0, t equals 3, the object is moving left. Okay. At t equals 3, okay, it's moving right. And there on so forth, it moves to the right. So that's all you need as far as this type of analyzing. Okay, just to recap, we took the derivative of the position, and we took the derivative of the position and gave us our velocity. And where's the velocity equal to 0? That's important because anything to the left of 0 is moving, anything below 0, it's moving to the left. Anything to the right of 0 is moving to the right. Take the derivative again so we can analyze what the acceleration is doing. Because the acceleration is 2, it's greater than 0, it's always positive. Okay? Meaning, whenever the velocity is going to the right, the acceleration is speeding up. Whenever the velocity is going to the left, it's slowing down. So if the acceleration was negative, it'd be the opposite. It'd be speeding up to the left and slowing down to the right. Okay, let's try this again for example number 4. Okay, here's our equation. And first thing we need to do is take the derivative to find dt. And then set it equal to 0. Okay, in order to do this, we need to factor it out. Starting with the 3, and then taking care of the inside, leaving us with the points 2 and 4. Now that we know where the velocity is 2 and 4, I mean 0 at 2 and 4, that means the slope at those 2 points, okay, is 0 at 4 and at 2. Next, we need to find the acceleration, so take the derivative of the velocity, and we get 6t minus 18, make it equal to 0. Okay, to both sides, divide by 6, divide by 6, and t equals 3. Okay, so let's draw our critical points. We have bt at 0 here. There's 2, equal distance 4. And then where are they positive? Where are they negative? So now we need to see what's happening to the left, to the right of 2, and good going, and to the right of 4. All you got to do is plug in a number between 0 and 1. So I mean 0 and 2, and we can just plug in the number 1. Okay, so plugging these numbers in, plug it into the factored form right there. Okay, it makes it easier to analyze. If you plug in a 1 here, you know you're going to get a negative answer. If you plug in a 1 here, a negative answer, a negative times a negative is a positive. Okay, so this is moving to the right. This is moving to the right because it's positive and it's horizontal. If it's vertical, we show an arrow going upward. Now let's plug in a 3 somewhere in between here, 2 and 3, 2 and 4. Plugging in a 3, we know this gives us a positive. We know this gives us a negative, and we end up with a negative. So this is going to the left, and here for 5, it's positive, so it's going to the right. Now moving on to the acceleration, we need to look at the acceleration equation. Okay, so at 3 it's 0. To the left of 3, let's just check just so you can see. If you plug in a 1, you got 6 minus 18. You're going to get a negative number. Okay, a negative number. So everything to the left of 3 is a negative acceleration. If you plug in anything bigger than 3, such as a 4, you get 24. Anything beyond that gives you a positive number. Okay, so to the right of the acceleration, you have positive numbers. Okay, speeding up or slowing down, let's look at the motion. First, let's write down all the points. Here's t equals 3. Here's t equals 2. And, oh, sorry, that's not t equals 2. Oh, yes, it is. Sorry. And we have t equals 4. Okay, now that we know where the acceleration is negative and positive, okay, meaning before t equals 3, there's a force to the left. Okay, after t equals 3, there's a force to the right. Okay? So if the object is moving to the right, as it shows here, and there's a force to the left, it's going to slow it down. Okay? Slowing down over here. Ah, sorry. Okay, it's slowing. Okay. Okay, now remember this is t equals 3, but I wrote it above. Okay, wrote it above it. Now, the velocity at that point right here is moving to the left, and the acceleration's to the left. So now it's speeding up. Okay, if there's a force to the left and we're moving to the left, it's going to speed you up. Okay, so we have speeding up here. Again, we have a after t equals 3, we have a positive, but it's moving to the left. Since they're in opposite directions, we're slowing down now. Slowing down. And once again, the motion's to the right and the acceleration's to the right, so it's going to get that guy going faster and faster. Okay, so we are speeding up afterwards. Okay, now to analyze position, once again, we need to look at the position equation. And what are the positions at those points of interest? Meaning position at t equals 0, at t equals 2, and at t equals 4. Because those are the times t equals 0 is always the position of interest, because that's where it starts. Out the blocks, what direction is it moving? It changes directions at 2, changes directions at 4. So where is the object, the particle, when t equals 0? And if you plug in a 0 here, 0, 0, position equals 4. Okay. Following along in that pattern, continuing in that fashion, we're plugging in all the numbers we have here, we get 4. Okay. Here, for 2, we get 24, plugging in the 4, where the objects change velocities, you get 20. Okay. Since all these positions are positive, I'm going to go ahead and put 0 to the left, because we don't have to put it in negative numbers. To the left of 0. And at t equals 0, we're at 4. Okay, this is t equals 0. Come on in. We're at 4. And we're going to the right. Okay. Until 2 seconds, we get to 24. Position 24. Let's stop it around here. Position equals 24. Okay, from there, after 2 seconds, it goes to the left. Okay, all the way up to position 20. So yeah, let's go about right there. It's not to scale, but about right here is position 20. Okay, and then after that, it changes direction and goes to the right thereon after. Okay, and there's your position analysis. Go ahead and do examples 2 and 4. If you can, look ahead in the examples and do more. I'll give you the rest of the class time to finish the rest tomorrow.